Hi everyone, and welcome to the fourth video in the National 5 Unit 2 chemistry course. The first thing I'd like to talk to you about today is something called isomers. Now, we have been looking specifically at the alkanes so far. Now, if you remember, the alkanes are a homologous series, so a family of compounds. They come under a general formula and have similar chemical properties, and they all have carbon-to-carbon single bonds. Now, an isomer is not an isotope, don't get confused. We learned about the isotope in Unit 1. But an isomer is basically molecules with the same molecular formula but a different structural formula. So an isomer are molecules, isomers, because there's more than one, are molecules with the same molecular formula but a different structural formula. And to just kind of showcase this, I'd like you to think about pentane. So pentane, right over here at the side, Pentane, pent meaning 5, ane meaning alkane, remember? Yeah. So we have 5 carbons, 1, 2, 3, 4, 5. And we fulfill every valency on those carbons. So there are 4 bonds on every single one of these carbons. And those valencies are all filled with hydrogen atoms. And we're remembering our capital C's, our capital H's to get our full structural formula. And our molecular formula here is C5H12. So there's your full structural formula, there's your molecular formula, and then there's your name and where that's come from. Now, in the last video you saw me using a molecular model kit, and I made pentane for you already out of that here. So here we have our 5 carbons in a row. Now we draw them as if they're a straight chain, one after the other, but we have 5 carbons in a row. Now what I mean by an isomer here is if we're going to have the same molecular formula, we have all of the same parts. So if I wanted an isomer of pentane, I would go into my molecular model kit, I would pick out 5 carbons, I would pick out 12 hydrogens, but I would need to assemble it so it was not the same as this molecule. Now that's harder than you might think, because all of these bonds can twist. Look at that shape. The bonds can twist, they can make various shapes. So sometimes you might think you found an isomer, but you've actually just found a straight chain of pentane that's just got a little bit tangled up and a little bit twisted. What we need to do to think of an isomer is we want to change and swap groups on here. We want to break bonds and reform new ones. So if I take off the end CH3 group and I take off, it's a good noise, I take off a hydrogen from one of the inner carbons and swap these round. Look what happens. If I can get this hydrogen on this, there we go. Now I have 1, 2, 3, 4 carbons in my longest chain here, and we'll talk about naming these in a wee second. But we have 4 carbons in this longest chain, and no amount of twisting, you know about twisting, of turning or flipping around the molecule, is going to get me these 5 carbons in a row anymore. So this is an isomer of pentane. So if I look at that, and if you can see this here, what I'm going to do is I'm going to draw what I see. So the first thing I'm going to do here is draw 4, 1, 2, 3, 4. And my 5th one here, the way that I have it, is on this carbon. Now I'm going to fulfill all of carbon's valencies again, all around the molecule, and then we'll count and make sure that we have everything that we should have. Because remember we said they have to have the same molecular formula, but a different structure. And this is certainly a different structure. I'm just going to put this to the side just now. So I have 1, 2, 3, 4, 5. There's C5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 hydrogens. Same molecular formula, different structural formula. These are isomers. Quite important when you have a look at this. I've drawn this the way that I see it. I might have drawn this way around, and it would be the same thing. Look, all I've done is turn the molecule over, and look, this carbon that I had on this carbon here is now on the second one from the left. It's the same thing. So this is equal to, I'll just write that, C, 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 C. Writing all these in. So these are not isomers of each other. These are the same thing. I could also, pretend that's an equal sign, pretend that's an equal sign, because I'm going to do 2 more. Have drawn this, so this was my original one that I drew like this. I could have flipped it around. Same molecule, all I've done, rotate it. Yeah, flipped it around here, even rotating this bond here, it's the same thing. So I might have drawn 1, 2, 3, 4 with a carbon here, fulfilling all of my valencies. One, 2, 3, 4, 5 carbons, 12 hydrogens all around. And just to show you that something else that's the same thing, how did I have this before? This is this molecule. If I come back to the original way that I drew it, I rotated it this way to get this one. What did I do? Flip it that way to get something else. And this kind of looks a wee bit complicated, but all this is just showing you that these are the same thing. All I've done is rotate them. Yeah, so all my hydrogens are in, a bit messy. But I rotated. I rotated here. I rotated here. And I rotated here. So the things in this box, or on this edge of my page, these are the same molecule. Not isomers. Okay. So this molecule is an isomer of this, but these are all the same thing. All I did was take this and I rotated. I take this and I rotate, I take this and I rotate. It's the same thing. All I'm doing is taking this. I'm not breaking any bonds. You would need to break bonds in order to make an isomer. There's one more isomer of pentane as well. Now think about what I did last time. Last time I took the carbon that was on the end of the chain and I broke it off. I took a hydrogen that was in the middle of the chain. Now looking at this, this is an end, this is an end, and this is an end. This carbon is the middle carbon. There's my middle hydrogen. I broke that off. Breaking bonds, and then making bonds by switching them over. And if I can switch them over, look at what I've made now. This looks a bit complicated, yeah? But let's have a think. I need to look for my longer chain, which is now 3. And that middle carbon has 2 other carbons coming off of it. So if we draw this, we'll do this on a different sheet of paper. If we draw this, I end up with carbon, 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 the one in my hand. This middle carbon has 2 more carbons coming off of it. So I have a middle carbon with 4 carbons on it altogether, and then I draw in my hydrogens. Okay, 1, 2, 3, 4, 5, C, 5. Now remember, these numbers have to be subscript, so they're small. That's not very small, it's just so you can see it. But capital C, small number, subscript, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 hydrogens, H12. So from pentane to this one, which can rotate, to this one here, sorry, C5, H12 has 3 isomers. That's how we work it out. That's what we look at. So I would like you to maybe try is to see, well, what about isomers of C4, H10 or C6, H14. Something for you to have a wee go. Just in a bit of paper, draw them out, break ends off. You don't have, you know, the last time I said you could use blue tack and cocktail sticks. If you don't have something like this, just look at your structure, draw it out the straight chain first. I'm taking off a CH3 and I'm swapping it with one of the hydrogens in the middle of the chain. Once I have that isomer, again, just looking at this one, I take off the CH3 and I swap it with a hydrogen in the middle. So you can do it with a physical molymod kit or on paper, but it's for you to identify if you can get isomers or not. And next time we'll talk about how we can name all these different molecules.